What's up, Open School? Mr. Kim here with one-step and two-step algebra problem solving. And algebra, that's my cat Oscar here with me helping out. Algebra is the system for solving problems with unequal parts. Algebra was invented over 1,000 years ago, and you can just imagine at the time that algebra was invented, somebody doing some trade across borders and having different currency. And if they had their donkey loaded up with tea, bags of tea from their home country, and they know how much money they can get in their home country, but they heard in a neighboring country there was a better price being paid for tea. There was a tea shortage. So you load your donkey up and you go across the border and you start bartering and negotiating, but the currency is completely different. If you only had adding and subtracting, it might be very difficult in order to come up with what a fair market value for your tea would be. And algebra is the kind of math that comes to the rescue and helps people solve equations, problems, math, real life things that are so unequal that you wouldn't think you could even find a solution. You say, wait a minute, I'm not going to take any tea across any country borders, and if I did, I've got my iPhone, so what do I need algebra for? Well, everybody can benefit from having good problem-solving skills because we all encounter problems on a daily basis. Some of these problems are obviously more complex than others, and it would be wonderful to have the ability to solve all the problems efficiently and in a timely fashion without any difficulty. Unfortunately, there is no way in which all problems can be solved. But algebra is one of the things that can help us understand some basic stages of problem solving. Because effective problem solving usually involves working through a number of stages or steps. The first step we're going to work with in problem solving is problem identification. What kind of problem am I facing? What kind of things am I going to have to recognize in order to identify the nature of the problem? And that's what we're going to look at first, is just problem identification. So in algebra, as we start to look at some problem identification, we do work with variables, and in this case I'm going to use v because it was one of the variables that was used in one of our first one-step equation problem-solving sheets. Well, there are things that can happen to v that create an imbalance on one side or the other of the equal sign. And if I want to know what v is, I want to end up with a state where v is by itself, and whatever value v has, I want to know what is equal to v. So my first problem is going to be to identify what things are being done to the v. And in the very first problem that we have in our worksheet, we have 8 plus v. So whatever the value of v is, v could be that bag of tea. And I want to know just what the bag of tea is worth. But here I've got a problem because I have 8 added to the bag of tea. Now, ideally, I want to consider any time there's addition or subtraction to v, I want to set up a case where nothing is being added to v. Nothing at all. I want v by itself. Well, if I'm going to add nothing to v, one of the methods I can use is to turn that 8 into a 0, because 0 will add nothing to v. And in this case, I'm adding 8 to v. I'm adding 8 to v. So I subtract 8 from 8. And when I subtract 8 from 8, I'm left with 0. And if I add 0 to v, if I add 0 to anything, if I add 0 to the bag of tea, or 0 to my fleet, a very impressive fleet of 4 donkeys, if I add 0 donkeys to my 4 donkeys, I'm left with exactly what I wanted to know, what the value of v, or what the value of the variable is. So the first condition of v is it can have something added to it. What other things can happen to v? We can have something taken away from it. v minus 8. And if there's something that's being taken away from v, my goal is again to make it so nothing is taken away from v. So if I had v minus 8 and I wish to know exactly what the value of v was, I could simply add 8 to the 8. And if I had minus 8 and I added 8, it again would equal 0. So I would be taking 0 and subtracting it from v. And if I have v and I subtract nothing from it, I'm left with exactly what the value of v is. Now there's 2 other conditions, and they're a little less intuitive. The first condition that I'm going to talk about is if I had v divided by 5. And when it's a fraction, when it's set up like a fraction, v is being divided by 5. The fraction bar actually is the division sign. So that says v is being chopped up into 5 parts. v is being divided by 5. And if I wanted to have v be by itself again, this is where it's a little different. My goal is to multiply v times 1. Is if I take v times 1, anything multiplied times 1 is just exactly what the thing is. If I had 4 donkeys and I multiplied 4 times 1, 4 times 1 is just 1. So in algebra, because we're using letters all over the place, and x is one of the common letters that we use, we substitute in a dot for the times symbol. v times 1 equals v. Let's go back to our problem, and let's take a look at v being divided by 5. Well, the undo, or the inverse of something being divided by 5, and I'm going to just look at some fractions for a minute. If I had 1/2 and I wanted to do something to turn it into 1, I can multiply it by the inverse, or the reciprocal of 2 over 1. And when I multiply 1/2 times 2 over 1, when I multiply fractions, I multiply straight across. 1 times 2, that's 2, and 2 times 1 is 2, and 2 over 2 equals 1. Anytime I have a fraction that has the same denominator and numerator, it cancels itself out. It says 2 divided by 2, and there's exactly 1 2 into or in any fraction that has the same numerator and denominator, and so it will always equal 1. So let's go back to our situation where v is being divided by 5. Following that same logic, if I multiplied it times, pick another color, I'll do it in magenta. If I multiplied v, which was being divided by 5, by 5 over 1, multiply this, then I multiply straight across just like before. 5 times v is 5v. I don't know what the value of v is, but I've got 5 of them now because I multiplied it by 5. And 1 times 5 is 5. And when I have 5 over 5, how many 5s are in 5? It cancels. There's 1 5 in 5, and I'm left with 1v. And anytime there's something, a number, up against a variable, 1v, it always means 1 times v. Any number that's pushed up against a variable, 3x, that means 3 times x. 9w, 9 times w. That's how we read that. So 1v is 1 times v, and anything times itself is just v. So by convention, we erase that. Now we also understand that the v is always there. So if I have x, here's an x, I understand that what I really have is 1 times x. And that'll come into play later. I just want to make the point that secretly there's always a 1 that's hanging out there by every lone variable. 1 times it. That's what's always there. And I'm going to go ahead and make a leap right now, and I'm going to make a point that if there's a negative variable like negative w, what that really means is it's equal to negative 1 times w. So it's negative 1 times w that makes it a negative w. Wow, got pretty far afield right there, but all of those things are the intuition you need to have to be an effective problem solver. So, just hitting that one more time real briefly, if I have v being divided by 5, the undo operation is to multiply it times 5. And what I'm really doing is multiplying it by 5 over 1. But what some people will do is they'll take a shortcut, v divided by 5, and they'll just multiply it by 5 and cancel the 5s. The shortcut's okay as long as you know the long way around to the thinking. Now, the final condition that we can have our variable in, we've already discussed it. And that is 5x, meaning 5 times x. And to get x by itself, to evaluate x by itself, I'm going to divide 5x by 5. And when I divide 5x by 5, how many 5s are in 5? Well, there's 1 5 in 5, so it becomes 1x. But remember, the 1 isn't really used, so it's like it's not even there. And so I'm simply left with x. So those are the 4 conditions that we identify in one-step and two-step equations, the 4 initial operations on a variable. Now there are more operations on a variable that we might have to undo, but as we introduce one-step and two-step equations, these are the dominant 4 operations that you're likely to see. So I'm going to look at